Hello fellow Unreal Engine artists, designers and developers. In today's tutorial we're going to create our first geometry script. We're going to recreate the tunnel segment that we created manually in a previous tutorial, but this time it will be automatically generated and we can change parameters at any time in the future. Let's get started. Geometry scripts are a way to automate and parameterize the creation of your static meshes. If you remember right from the beginning of this series, we've been using the modeling mode to manually create items such as our walls, doors, windows and tunnels. And geometry script enables you to take any of these functions and add it into a blueprint script to automate the creation of elements. So today let's start off with a simple recreation of something we did manually in the past, and we'll create this tunnel segment with various parameters. So you can see on the right here I've got radius, wall thickness, segment length, and I can dynamically change those elements to create a new variant of this. And I've also added a function to generate the static mesh asset when I'm happy with the final outcome, and that can then be used throughout my level. So let's begin creating the geometry script, and we'll do it step by step. Before we can do anything, we need to make sure that the geometry script plugin is enabled for our project. So off to our plugins directory, and if you search for geometry, you want to enable geometry script. So click on that, do a restart, and then we'll start to create our new geometry script. Into your content browser, go to your tools folder and we'll create a new blueprint class. And if you search in all classes and search for dynamic mesh, you will find this new class called generated dynamic mesh actor. So let's select that and let's name this GS for geometry script underscore tunnel, and then open that up, and let's put it on the right hand side of the screen, and that way as we create this we'll be able to see how it appears in the level. So the first thing you need to do is you need to override a function that is going to generate the dynamic mesh. So when you're creating blueprints you often use things like construction scripts to create elements. This has got a slightly different function for generating, so you need to go to the functions and override on rebuild generated mesh. That's like a construction script for geometry scripts. So if you click on that, and we can get rid of other events here, and we've got this event on rebuild generated mesh, and the target mesh here is going to be the dynamic mesh that it creates, and we'll want to store that at some point so that we can then use it to generate a static mesh at the end. But let's start thinking about the steps that we took to generate the tunnel. The first thing we did is we created a box. So let's drag off here, and if you do append box, this is the function for creating the box. So there's append box, append sphere, append polygon. There's lots of different variations. That's the shape tools that you saw in the modeling. If you do append box, you'll get all of the different parameters for creating a box. So dimensions, how you want to subdivide them. Remember, for our splines we need subdivisions so they can smoothly wrap around the curves. So let's start thinking about creating some parameters for this. We'll create new variables. We'll do a radius, which is a float, and all of these are going to be visible so we can change them in the editor. Then we'll duplicate this, Control D, and we'll do a wall thickness, also a float, duplicate again, and we'll do a segment length. So those are really the three dimensions that we're interested in. And now we'll plug these into the append box. So the dimension X, that's along the spline, that's our segment length. So let's drag that in here. And that's our segment length. The dimension Z is the wall thickness. So let's drag that in here. And the dimension Y is the size that we're going to warp the box around. Now, we've put in the radius that we want. What we need to do is calculate the dimension that we need here so that when we wrap it, it will be exactly that radius. And again, if you remember from when we did this manually, we used the formula of 2 pi r to work out the circumference, and then half the circumference for our tunnel piece was pi r. So all we need to do is take the radius out. Let's use control there, and you can do a multiply by pi. Multiply, and you see that's a function here in the maths. So multiply by pi, and then we'll plug that into the dimension y. Okay, so far so good. Now let's think about the steps that we want. So for our x dimension, that's going to be along the spline. That's where we want quite a few steps so that it can smoothly warp that round the spline curve. So let's make that 16. The y dimension, which is the arch of the tunnel, we need to have a few steps there as well. So I'm going to make it 32, so it's nice and smooth. And the thickness of the tunnel we don't care about because that will never deform, so we'll leave that at 0. So that looks good. Let's do a compile. And at this stage, it might be worth dragging it in and see what happens when we change these parameters. The nice thing with geometry scripts is you can put them in your level, and as you create them, you can see how it affects the outcome. So let's go into our newly created element and drag it in here. And let's create some radiuses. We probably need some defaults here as well. So let's go back to the geometry script and let's go to our radius and make that a default of 250, the wall thickness a default of 40, and the segment length a default of 400, and do a recompile. And we're not seeing anything at the moment, and that's just because I haven't connected my target mesh to the append box target mesh. So let's connect that, do a compile, and here we see a box that's been generated, and let's lift it up in the air because ultimately it's going to be warped. So let's put it up in space a little bit, and now you can change the parameters and see what happens. So you can change the radius, and you can see that it elongates that before we're going to warp it. You can change the wall thickness, so let's make that a thicker wall, and we can change the length of the segment as well, so the depth of the segment along the spline. So first stage is working. Next thing we want to do is we want to apply a warp to warp this box so that it makes the semicircular arch. So the next step is to bend our box into our semicircular tunnel. So for that, if we drag off here, we'll use the apply bend warp to mesh, and make sure you drag the target mesh in here. And you've got some options here in terms of how you want the warp oriented, what angle you want to do the warp, what length you want the warp to be. So let's let's just compile this and see what it's done in the viewport. So you can see at the moment it's kind of a strange warp at the moment. So let's come back here and look at things like the orientation and the angle. So the angle we want to bend it at is 180 degrees. And the orientation we want to bend it at, we'll need to make a transform for that. So down here, if you do make transform, and the transform will want to be rotated 90 degrees on the x-axis, and plug this into the bend orientation. And that's starting to look better, but at the moment the bend extent is only 50, so it's bending and then it becomes a straight value there. So the bend extent is half the length of this box, because we want it to bend half this way and bend half that way. So in order to work that out, let's drag that back here. Let's go full screen so we can see everything here. And let's create a bit of space. So back here we had our dimension for the length of the box that we were stretching, or sorry, rather we're going to warp around. So we use radius multiplied by pi. We want to take that, but we want to halve that for the bend extent. So drag out of here, do a divide by 2. That gives us half that length, and that's how far we want to bend. So that goes into the bend extent. So compile that and let's have a look, see what we've got. Perfect. So now we have the half tunnel we want. And again, let's play with the parameters and see if we can create some variations. So different radius, that's fine. Smaller radius there. Wall thickness, we can make smaller wall thickness, and segment length all still work. So this is all good, and the only thing that's really missing from this at the moment is that the pivot point is at the bottom of the original box. That's not going to be very useful when we use this in a spline, because it's going to bury the tunnel underneath the spline. We want this pivot point to be at the bottom of the semicircle. So let's do that now. Okay, to move our pivot point, we've got a function that we can add here called translate pivot to location. If I can find it. Yeah, translate pivot to location here. And again, let's plug in our target dynamic mesh, and we have our pivot location here. Let's split this out into the X, Y, and Z component. Now we don't want to change the X or Y components because they are in the center, but we want to move the Z location down, and because currently it's at the outside, or the start of the box, we want to reduce it by the radius that we set up in order to get it at the bottom of the box. So that's very simply done. We'll drag in our radius, and we want to adjust it by the negative of the radius. So let's do a multiply by -1 here to make it negative. And then finally we will plug that in to the Z location. So now that will reduce that location by the radius on the height. So compile that, and let's do a quick view in the level. And you can see now that the pivot point has moved from the top of the structure down to the base of the structure. And so if you hit the end key now, you can see that the structure sticks to the ground. And let's just check that works if we change parameters. So let's go up here, let's change the radius to 500, and you can see that even though it's a bigger arch, the pivot point is still correctly calculated as the negative radius. So again, we can hit the end key and pin it to the ground. Okay, so that's good. We've created our structure. The only issue now is that it is a dynamic mesh, and if we want to use it in our structures, like the tunnel I've created over here, we need to convert it into a static mesh asset that we can use in this spline. So let's now look at creating a function to generate our static mesh asset. And of course, we can come back and change it any time and regenerate the static mesh asset for quick changes. Now we're going to create a function in our geometry script to generate the static mesh, but the first thing we need to do in our existing script is we need to store the dynamic mesh reference. So all along here we've been building up our dynamic mesh. Last thing we want to do is right click, promote this to a variable, and let's call this variable dynamic mesh. And this will be the input to our generate static mesh function. And now we'll create a new function. So do plus in the functions, and we'll call this generate static mesh. And over in the details, make it call in editor, and that way we'll have a button on the screen that we can click when we want to generate our mesh. And what we want to do is we want to create a new static mesh from the dynamic mesh, and there's a function for that, which is create new static mesh asset from mesh. So if you click on that, it asks what dynamic mesh we want to use. Well, we've got our dynamic mesh variable here, so we can drag that in here. And we're going to take that dynamic mesh in and create a static mesh out. Next thing we need is an asset path and name. So I'm going to create a separate asset path and asset name string and then combine them together. So down in your variables, let's add a new asset path, and the type is going to be string. Make sure it's visible so the user can change it, and then Control D to duplicate, and let's call this asset name. Now let's drag these in to our graph, and now we can start to construct the whole string. So from the asset path, if you do append, and actually we'll swap it to the second one here. We need to create a little bit of extra space for doing this. So the start of the string is /game/. That's the internal name for our content folder. So /game/ and the asset path. And then we'll need to do another append. In fact, the easiest thing to do is just to duplicate this one here and take the output from here, and here we're just going to add a slash between the asset path and the asset name. And then finally another append, and this will take the elements we've created so far and then finally the asset name. And now we've got a string with the game prefix, the asset path / asset name, and that can go into the asset path and name. And there are some options here, but let's just see, before we look at the options, let's just see what it creates if we don't change any of the default options. So let's compile this. Let's go back to the main level here. So we should now have a generate static mesh function here. So asset path and name. So let's call the asset path meshes and asset name SMGS tunnel. And if I click on generate static mesh, don't know if anything's happened because you don't get any feedback here, but if I go into the content browser, I've got a folder called meshes, and there is a new static mesh called SMGS tunnel. So that looks good. Let me just drag it into the scene. That looks pretty good. And let's try adding that to our spline here and see how that works. So in our mesh here, I'm going to change this to SMGS tunnel. And there's the new mesh here. And let's go into play mode and see what happens. If I do play and I go through here, it looks good. What about if I go to the end? Now the collision isn't working. So that's one thing we'll need to fix. We'll need to make sure that the collision is enabled when we're creating the static mesh. And the other thing we haven't also considered is materials. At the moment we've generated it with a blank material, but we might want to actually add the correct material, brick material or whatever, to the tunnel. So let's look at both of those. Now, before we get into collision, I just realized I accidentally put instant replay on my video card. So apologies for the widescreen format and the probably crackling audio as well with the extra strain on my PC. So I've switched that off, so hopefully the rest of this tutorial should be a little bit better in terms of video and audio quality. Right, with that out of the way, let's figure out how to add collision to our static mesh. So I mentioned these options before, and we'll need to set those up to enable collision. So if you drag off here and do make geometry, it's a really long-winded name, make geometry script create new static mesh options, and you'll notice here it has various settings. Some of them are quite interesting actually. If you wanted to have nanite meshes, you could enable nanite here and then set up the nanite settings. So you could always do that. But the one we want though is enabling collision. So it is enabled, but it's enabled to the project default. And what we want, because this is a tunnel and we want to be able to go through the tunnel, we'll use complex collision as simple. And that collision will then have the same shape as our original box. So it'll allow us to go through the tunnel, but not through the walls of the tunnel. So with that set, let's compile. Let's go back to our modeling mode and let's regenerate the static mesh. Okay, nothing seems to have changed, but if we go into play mode and we go up to our tunnel, we now can't walk through the walls. So we can go through the tunnel, but we can't walk through the walls of the tunnel. So that's worked nicely. So now let's finish this off by making sure that the materials are assigned to the dynamic mesh and then are also assigned to the static mesh. Now, the eagle-eyed amongst you will have noticed that when you select your geometry script, that there was a material attribute here which defaulted to the world grid material. So let's change that so that we assign the brick material, and then let's see if that is copied over to our static mesh. So I'm going to change the material here, search for the brick material that I have used in the past, and you can see that I have the bricks laid out the way I want with the archway of bricks as well. Now, if I do generate static mesh, nothing appears to change in the generated static mesh on my spline tunnel. And that's because you have to explicitly copy the material over from the dynamic mesh to the static mesh. Luckily, it's quite a quick and easy thing to do. So let's hop over to the geometry script blueprint, and here we will set the material. So what we can do is we can grab the dynamic mesh component. So use Control to drag that out. And if you do a get material here, it will get the material at a particular index. Now I'm just dealing with a single material on this particular mesh. If you want to use geometry script with multiple materials, you would have to iterate through the element indexes and pick them up from the dynamic mesh and then add them to the static mesh. But we'll keep it simple for this example. And now we will take out the pin from our static mesh asset that's been created and do set material. And we want to set material on a successful creation of a static mesh, and we're going to set it at the same index. So from index 0 to index 0, and we'll get the material out from the dynamic mesh and put it onto the static mesh. And that should be all we need to do. So let's compile that, come out here, and now if we do generate static mesh, after a couple of seconds, we have the new mesh here, and it has the material attached as well. So now we finally have our material and our collision sorted out. And now if we do any changes, so if I come out here and I say I want a bigger tunnel, I can drag this, make it maybe 400 radius, do a regenerate, and it will instantly be available in the level with the collisions and the materials. So this is all looking good. And in the next few videos, we'll do more geometry scripts. So we'll do some more sophisticated geometry script work. And as always, stay subscribed for those future lessons. And I'll see you then. Bye for now.